Okay, hello students. So in this video, we will study about the solution to the differential equations. Okay, so I will take a simple example here. For example, uh, I have this differential equation y double prime minus 5y prime plus 6y is equal to 0. Okay, and for now, I'm going to tell you the solution up front. For example, y is equal to e to the power 2x and y is equal to e to the power 3x. If you want to know whether these functions are solution of this given equation, say equation 1, what are you going to do? You will find dy by dx. Basically, what you will do one by one, if you want to check this function is a solution to this equation 1 or not, what will you do? You will calculate dy by dx and then you will calculate d2y by dx square, and then you will put these values, this one, and value of y itself. So it should basically satisfy the equation or given differential equation. Okay. Similarly, this also, y equal to 3x also, right? So you will find that I'm not going to do it here. My purpose is to show what you mean by those solutions. So basically, if you write a function which is a linear combination of these two given function, okay, for example, C1 in terms of some constant e to the power 2x plus C2 e to the power 3x. All right. So this is also going to be the solution of equation 1 or solution to the given differential equation for any value of C1 and C2, right? So this is what we mean when we say we want to find the solution of a differential equation. All right. Now, there would be a time when you won't be able to write these functions in a separated function. For example, explicit function y equal to fx. Here I was able to write, right? Y equal to fx. There can be a time when solution of a differential equation will be implicit. I think you understand what is the meaning of implicit and explicit. Okay. So it would be difficult for you to find the solution. Basically, that's what I want to point out. I'm just going to, tell you a couple of things. For example, when this solution would be implicit, if we consider a differential equation dy by dx is equal to y square upon 1 minus xy. When you will find the solution of this differential equation, your solution is going to be, I know the solution, but I'm just going to make the base for you to understand some broad perspective of the differential equation. So can you write this equation in terms of y is equal to fxy, sorry, y equal to fx? No, right? So this is not a separated or separable equation. Okay. This is not a separable equation. Okay. Also, if you have a differential equation where you can write the differential equation in terms of separable equation, that means you can separate the fy function, you can separate the fx function. Don't you think it would be like easy to get the solution of differential equation? It would be, right? So for example, this is the easiest form of differential equation, right? To find the solution, what will you do? This is, you'll just integrate it and you will find the solution. Y is equal to whatever integration of fx you will get plus some constant. All right. Now, there would be a time when you don't know the integration. For example, e to the power minus x squared dx or sin x by x dx. So whenever you talk about this indefinite integration, then okay, in terms of differential equation, if you are trying to find the, let's say, definite integral, let's say from x1 to x2, then between that x1 to x2, this integrand has to be defined. Okay. Basically, what I'm trying to say is sometimes it is difficult to solve the differential, to solve the integration itself. Okay. Then how do you approach? You approach numerically. Okay. You try to solve the numerical solution, or you try to integrate the numerical, you try to integrate numerically. Okay. Or in another word, you can say you try to solve the differential equation numerically. I will tell you in how a couple of standard method how to solve those differential equation numerically in further different videos. Okay. So basically, you will solve this differential equation numerically. Okay. Now, I'm going to today in this video, I'm going to introduce one method of solution of differential equation. Okay. So, which is what? So far, what we were trying to establish is when your differential equation can be written in separable equation fx into gy. Okay. So you separated the variables of y separately and variables of x separately. Now what will you do? Dy by gy is equal to fx dx plus c, and here also you can integrate. Okay, then you can find the solution to the differential equation. All right, now moving on, you will just introduce one complication. Okay, then we will see how we solve those kind of differential equation, that is homogeneous homogeneous equation. Now, in this video, we will find the solution of how you find the solution of a homogeneous equation. So, before we go there, let's understand what is homogeneous function. Okay, this is important. Homogeneous function. Okay, so when you understand homogeneous functions, how do you define a function to be homogeneous? Let's say you have a function fxy. Okay, and you replace x with tx, you replace y with ty, what will you get? Tx comma ty. You should get t to the power n f of x comma y. Then this fxy is said to be homogeneous function of degree n. Okay. If you can write a function in this format, then that function is called homogeneous function of degree n. I will give you examples. For example, x square plus xy. Okay. You can write x uh, in place of x, you can write ts. In place of y, you can write ty. What will you get? T square, right? And then x square plus xy. Compare this with this thing standard. What is the degree of homogeneity here? This is 2, right? And how about this? Root of x square plus y square. If you have this function, I'm sure it is very easy to get this, right? T to the power 1. So what would be degree for this function? 1. How about this? Sine x upon y or y upon x. It doesn't matter. You will get t to the power 0 sine x upon y. That means degree is 0. Okay. So once you have understood the homogeneous function, let's move on to the uh, homogeneous differential equation, right? So let's say you are given a homogeneous differential equation m xy dy plus n, sorry, this is dx. Okay. You have been given mxy dx plus nxy dy is equal to 0. All right. Now, it is said to be a homogeneous differential equation when m and n, okay, they are homogeneous function. They are homogeneous function of same degree. Make note of this, same degree. So this differential equation is homogeneous differential equation when m and n are homogeneous function of same degree. You can easily find out the way we defined homogeneous function earlier. Okay. If they are like that, can you write dy by dx is equal to minus m by n? You can, right? And this is going to be another function fx comma y, right? Now, intuitively, can you tell me the degree of this m by n? By the way, if m and n are of same degree, just imagine what I just taught you earlier. T to the power something, let's say n1, mxy, and here t to the power n2, nxy, right? And n1 and n2 are same. They have to be of same degree, okay? Then if n1 and n2 are same, they can be cancelled out. This is nothing but m by n. So what is the degree here? Degree is 0. So this dy by dx will have a function of homogeneous function of degree 0, right? Then just replace x, sorry, not x, t. Remember earlier we replaced x by tx, y by ty. Here take t is equal to 1 by x. Okay. Then x will become 1 and y will become y by x, isn't it? So what did you get? dy by dx is equal to f of 1 comma y by x, right? And if you'll assume y by x is equal to z, what will you get? F of 1 comma z. Why are we doing this? I will tell you. I'm just trying to derive a method so that you can use it as a general methodology for a homogeneous differential equation. Okay. Now, if z is y is equal to xz, can you write dy by dx is equal to x into dz by dx plus what? Z, right? Yeah, z plus just function by parts, you can differentiate it. And this dy by dx is what? F of 1 comma z. Why did we do this? So, because we want to convert the differential equation into separable equation. Now you can separate z function f of z separately and f of x separately. What will you get? dz upon f of 1 comma z minus z is equal to x dx. Now you can easily integrate it. Of course, integrand has to be integrable. If you cannot integrate these functions, then what will you do? You will find those integration value numerically or some standard method. Okay, that you will see once you have understood, enough about the differential equations. Okay, now I will take a small example to apply that. So just to summarize, if you have been given mxy dx plus nxy dy is equal to 0 and m and n have same degree, then you convert dy by dx is equal to minus m by n. You convert this into some y equal to, sorry, some z is equal to y by x equation. You take z equal to y by x and convert dy by dx and make the differential equation into separable form, and then you can easily integrate it. Okay. Now, let me take the example. Okay. Example is x plus y dx minus x minus y dy is equal to 0. You can see m and n have same degree. They are homogeneous function of same degree and degree is 1. So dy by dx will be a homogeneous function and that will have what? 0 degree, right? dy by dx. So dx goes that side, x plus y upon x minus y. Okay. Now what will you do? You will put z is equal to y by x. You just divide denominator and numerator by x. This would be 1 plus z upon 1 minus z. And dy by dx is nothing but we just solved earlier z plus x dz by dx. Okay. From here, you can find, you can actually separate z function separately and x function separately. You can just do some mathematical manipulation here. You will get into dz is equal to dx by x. You integrate it. What will you get? 1 upon 1 plus z square dz can be integrated into tan inverse z minus half this, just multiply by 2. You will get 1 plus z square is equal to ln x plus c, right? Now you can just put value of z, which was nothing but y by x, tan inverse y by x minus half log of x square plus y square. Sorry, here it would be what? Hang on. Z is equal to what? Y by x. So this upon x square is equal to log x plus c. And once you will simplify this, this log x will be cancelled out. And on the other side, you can just simplify is equal to half. Half will be, by the way, taken on the root side. You can take just to, put it in the standard form. Log of root x square plus y square plus c. Okay, so this is the solution of given homogeneous differential equation. Okay, so thank you so much for watching the video. Do subscribe to the channel and let me know if you have any confusion and you can, yeah, you can give your feedback. Thank you.